So I wanted to do a real quick video on how you could check your answers by graphing, especially on Desmos. It's super easy. You take the original problem. So in this case, I'm doing the negative 36, the negative 9 times c raised to the 1/2. That's the original problem. You take that and you go put it on a Desmos. You're going to put whatever's on the left side on one line, whatever's on the right side on the other line. So here's what I mean by the line. Now, notice I did put y equals in front of both of them. For this part right here, it wasn't necessary, but it absolutely is necessary for this one. So I put y equals in front of it. Y equals negative 36. That's what gave me this red graph down here. I put y equals negative 9. I put in x instead of c because Desmos likes to graph x better than it does c. It will do c, but it's just easier to make every variable be x. X minus 12 raised to the 1/2. I graphed those each, and find the point of intersection right there, it tells you that it's 28. So the 28 was the x value that I got right here, the 28. I did another one. I think I did this problem right here. I put the square root of 2x plus 3 equals to x plus 2. I put that in the calculator, so I'm going to turn these two off. I'm going to turn these two on. I do need to fix my window so I can see that better, so I'm just going to press home because I had zoomed out. This one's really interesting. You can see that they're just touching each other right there. They don't really cross. And it came out to be, they touch each other at -1. And again, that supports my answer right here of -1. And lastly, I want to check this one that had no solution. So again, I went to the original equation, the square root of a plus 9. I'm going to enter it as x plus 9 is equal to the square root of a minus 1. I'm going to enter it as x, square root of x minus 1. So I went to Desmos and I entered those two equations. Yes, I put y equals in front. It just keeps things easier to do it the same way every time, since it works sometimes. Sometimes they work with the y equals, sometimes they don't. It's just easier to always put y equals. So there's the y equals x plus square root of x plus 9. Here's the y equals the square root of x minus 1. And you see that they never intersect. It doesn't matter how far you go out. I'm out at 126. I'm out at 144. You can scroll like this forever and they're never going to intersect. So while they may not be what we call parallel because they're not lines, they do not ever intersect. So that's why we do have to check to make sure that we don't get imaginary answers, and then we also have to check to make sure that the two sides do equal each other. I really should have done that checking up here as well. So let me just show you real quick. I should have checked. -1, if you plug it in, 2 times -1 plus 3, does that really equal -1 plus 2? And -1 plus 2, I believe, is 1. And the square root of 2 times -1 is -2. -2 plus 3 is the square root of 1, and the square root of 1 is 1. So we end up with two things that are actually equal. The same thing would have happened right here. If we checked this one, they would have intersected in two places. So that's why we got two answers. And if we plug them in and check, they would both end up equaling each other like they did right here. So there is a way that you can check your answer. I know that you guys you like the digital assignments because you get immediate feedback, but there is a way to get immediate feedback even if you're not doing a digital assignment. And this is how you can do it. Check by graphing.